So now we're going to kind of move on to this slightly connected topic, which is how to write equations in the form a times b to the ct. So we're looking at this variable c, which is kind of a new variable, and it will go along with what we did in the last time. So that's where we put our balancing number, the number where we were going to kind of balance out the conversion. And at one point we did, right, that this tells us are things happening more or less often than whatever measurement we have for t, whether that's years or seconds or months or whatever we happen to have. So we're going to look at three basic equations and kind of talk about how we can read them. So the first one, and really all of these three equations, we have the same start value. So that's still the same. In every single one, I have 1.05, so there's a 5% growth rate also for all three. So the rate that this happens, and it does say we're assuming t is measured in years. So if I have a 1t, that basically just means yearly. If I have a 6t, that means it's happening more often than a year. So this is 6 times a year. Okay, or we could say every 2 months. And if we look back at those problems, right, like let's say something was monthly, we used a 1/12 for the base, and then we had a 12t on the outside to say things are happening 12 times a year. Right? This is 6 times a year with a 6 in. The next one should kind of remind you of the half-life formula. So this is slowing down time because we're dividing. So the 5% growth happens every 6 years. So we have to wait longer than a year. We have to wait 6 years, which goes along with half-life. Like if we said the half-life was 6 years and we had the half-life formula, that's where the 6 would go. Okay, so this is kind of summarizing. When the growth happens once per time unit, years here, t is by itself, the first one. When it happens more often than the time unit, so more often, right, t is multiplied by how many times more often. When it happens less often, the time unit t is divided by how many times less often. So if something takes 6 years, that's happening 6 times less often. It'd take a whole 6 years to do it. So to summarize, A is the initial amount, B gives us the growth or decay factor, which can lead to that percent, C is the number of times the initial amount has increased or decreased by the growth or decay factor in 1 unit of time. So if we're dividing, it's a fraction of it. And T is the unit of time, seconds, days, weeks, months, years. So we're going to look at a few more of these to kind of interpret them on the next page. So first we'll write some, and then we'll read them. So it says, write a function to model each of the following situations. So also very important, what is t measured? So we're in years. So I'm just going to write a equals. So we're starting with 500. We're growing at 5.2%, so that's going to be 1.052. And the growth is happening every month. So this is more often than a year. 12 times more often. So we're going to write 12t. Next one, t is measured in months. We are starting with 650. It's decaying at a rate of 16%, so I need to use a base of 0.84. And it's happening every year. So t is measured in months. A year happens less often, 12 times less often, so we're going to have to do t over 12 to show that it's taking 12 months or 1 year for that growth to happen, or decay to happen. Next one, t is measured in days. We are starting with 150. We are tripling, which gives me a base of 3. We are tripling every week, so this is less often than the days. 7 times less often, so we're going to do t over 7 because we have to wait 7 days for that to happen. So now we're going to read some of these. So here's a function that represents the change in a quantity over t days. So t is days. The function is increasing because our base is bigger than 1. by 5.5%. And then what time period are we working with? So we're dividing, so it's going to take longer than the days. 30 times longer, or it's going to take 30 days. And you could also see, because 30 days is typically a month, you could see it would take 1 month. The next one, 471.3 to the 60T. We are increasing because our base is bigger than 1 by 30%. Our T is measured in minutes. This is happening more often than the minute. So this is happening 60 times per minute, which we could also interpret as every second. The next one, we have decay for the first time because our base is less than 1, which gives me 0.0055, so we're at 0.55%. The T is just a T, so whatever I say my T is, that's happening every week. So if we don't have some change, that rate is happening for whatever the T variable is.